In new construction, the switch leg or pull lights must be run in conduit all the way from the switch to the ground fault circuit interrupter, or GFCI, feeding the first deck box. If it is a remodel and the existing switch leg is not in conduit, it is not required to be retrofitted into conduit. However, new extensions or modifications to the switch leg must be installed in conduit. The switch leg is the conductor that carries the unswitched power to the transformer or relay that controls the pull lights. In the event of a ground fault, the conduit provides a protective barrier to prevent electrical shock or arcing. You cannot use non-metallic or NM cable to return the hot leg to the panel if the switch leg is not in conduit. NM cable must be protected by an overcurrent device within a minimum of 6 feet of the point where it leaves the conduit. Both X10 relays and Jandy relays can be used to control pull lights, and both are designed to meet safety standards. However, it is important to follow the manufacturer's instructions for proper installation and use. X10 relays communicate wirelessly using a low voltage signal, while Jandy relays communicate directly over the alternating current or AC line. This difference does not affect the safety of the installation as long as both devices are used in accordance with their intended purpose. For maximum safety and compliance with electrical codes, follow the conduit requirement for the switch leg and do not use NM cable to return the hot leg to the panel. Consult with a qualified electrician for guidance on specific installations and code requirements. Let's delve a little deeper into the conduit requirements. The National Electrical Code, or NEC, provides specific guidelines for wiring around swimming pools to minimize the risk of electrical shock. The requirement for conduit on the switch leg is a key safety measure. It ensures that if there's a fault in the wiring, the conductive metal conduit will provide a path back to the source, tripping the circuit breaker or ground fault circuit interrupter and cutting off power to the circuit. This rapid response significantly reduces the risk of electrical shock. When considering a remodel, the NEC generally allows for existing installations to remain as they are, provided they were compliant with the code at the time of installation. However, any new work or modifications must meet the current code requirements. This is why the distinction is made between leaving an existing non-conduit switch leg in place versus requiring conduit for any new extensions or modifications. Now, let's examine the reasoning behind not using NM cable to return the hot leg to the panel. NM cable, while suitable for many interior wiring applications, lacks the mechanical protection and grounding capabilities of conduit. If the switch leg is not in conduit and a fault occurs, the NM cable could become energized, posing a shock hazard. The NEC mandates that NM cable be protected within 6 feet of where it exits conduit to prevent physical damage and ensure proper overcurrent protection. Regarding X10 versus Jandy relays, the primary difference lies in their communication method. X10 relays use a low-voltage signal transmitted wirelessly or over existing power lines, while Jandy relays use a direct connection to the alternating current line. From a safety perspective, both types of relays are designed to meet established safety standards when properly installed. However, it is crucial to follow the manufacturer's instructions meticulously. Improper installation can compromise the safety features of either device. One important aspect to consider is the load rating of the relay. Ensure that the relay is appropriately sized for the pull light's voltage and amperage requirements. Overloading a relay can lead to overheating and potential failure, creating a fire hazard. It's also worth noting that ground fault circuit interrupters, or GFCIs, play a critical role in pool lighting safety. GFCIs are designed to detect even small imbalances in current flow and quickly trip the circuit, preventing electrical shock. The NEC requires GFCI protection for pool lighting circuits to provide an extra layer of safety. In addition to conduit, other wiring methods are permitted by the NEC for pool lighting, but they must meet specific requirements. For example, direct burial cable may be used if it is listed for that purpose and installed at the proper depth. However, conduit is generally the preferred method due to its superior protection and ease of maintenance. When working with electrical systems, especially around water, it is always best to err on the side of caution. If you are unsure about any aspect of the installation, consult with a qualified electrician. They can assess the specific conditions of your installation and ensure that it meets all applicable code requirements. Remember that electrical codes are in place to protect people from electrical hazards. By following the code and using proper wiring methods, you can ensure the safety of your pool lighting system. Let's clarify a few common misconceptions. Firstly, some people believe that if the pool light is low voltage, the wiring doesn't need to be in conduit. This is not necessarily true. While low voltage lighting reduces the risk of shock, the wiring still needs to be protected from physical damage and potential ground faults. Secondly, some people think that they can use an M cable if they run it through a PVC pipe. While PVC pipe can provide some physical protection, it does not provide the grounding capabilities of metal conduit. Therefore, an M cable is still not permitted for the switch leg without proper overcurrent protection within 6 feet of exiting the conduit. Thirdly, some people assume that if they have a GFCI, they don't need to worry about conduit. While GFCI protection is essential, it is not a substitute for proper wiring methods. Conduit provides a physical barrier that can prevent faults from occurring in the first place. Furthermore, it is important to consider the environmental conditions in which the wiring is installed. Pool areas are often damp or wet, which can accelerate the deterioration of wiring. Conduit provides a moisture-resistant barrier that helps to protect the wiring from corrosion and damage. Another factor to consider is the potential for physical damage to the wiring. Pool areas are often high-traffic areas, and the wiring could be accidentally damaged by lawn equipment, pool cleaning equipment, or even people walking by. Conduit provides a robust protective layer that can prevent damage to the wiring. When selecting conduit, it is important to choose the right type for the application. Rigid metal conduit, or RMC, is the most durable option and is often required for underground installations. Electrical metallic tubing, or EMT, is a lighter weight option that is suitable for above-ground installations. PVC conduit is a non-metallic option that is resistant to corrosion, but may not be as strong as metal conduit. It is also crucial to use the correct fittings and connectors for the conduit. These fittings must be designed for use with the specific type of conduit and must be properly installed to ensure a watertight seal. When installing conduit, it is important to follow all applicable code requirements. This includes properly supporting the conduit, using the correct bending radius, and grounding the conduit system. Grounding is essential to provide a path for fault current to flow back to the source, tripping the circuit breaker, or GFCI. In addition to the conduit itself, it is also important to use the correct type of wire for the pool lighting circuit. The wire must be rated for wet locations and must be sized appropriately for the circuit's amperage. It is also crucial to use a ground wire that is properly sized and connected to the grounding system. The grounding system provides a path for fault current to flow back to the source, tripping the circuit breaker, or GFCI. Proper grounding is essential for preventing electrical shock. Let's discuss the specifics of X10 and Jandy relays in more detail. X10 relays use a technology called power line carrier, or PLC, to transmit signals over existing power lines. This technology allows you to control the pool lights remotely using a compatible X10 controller. However, PLC signals can be susceptible to interference from other devices on the power line, which can affect the reliability of the system. Jandy relays, on the other hand, use a direct connection to the alternating current line. This eliminates the need for PLC signals and provides a more reliable connection. However, Jandy relays typically require more complex wiring than X10 relays. When choosing between X10 and Jandy relays, it is important to consider your specific needs and preferences. If you want a simple and easy to install system, X10 relays may be a good choice. However, if you need a more reliable system, Jandy relays may be a better option. Regardless of which type of relay you choose, it is essential to follow the manufacturer's instructions carefully and to ensure that the relay is properly installed. A proper installation can compromise the safety of the system. Finally, let's reiterate the importance of consulting with a qualified electrician. Electrical work can be dangerous, especially around water. If you are not comfortable working with electrical systems, it is best to leave the job to a professional. A qualified electrician can ensure that your pool lighting system is installed safely and correctly, and that it meets all applicable code requirements. They can also provide guidance on selecting the right equipment and materials for your specific installation. Remember, safety should always be your top priority when working with electrical systems. Taking the time to do the job right can prevent accidents and ensure the safety of yourself and your family. Now let's talk about some scenarios to help visualize these concepts. Imagine you're building a new pool. The electrical inspector will expect the switch leg, that wire running from your light switch to the pool light's power source, to be encased in conduit. This conduit acts like a protective shield. It's not just about burying the wire, it's about ensuring that if a fault occurs, the electricity has a safe path to ground, tripping the breaker and preventing a shock. Now picture renovating an older pool. You find the original switch leg isn't in conduit. Here's the deal: you don't necessarily have to rip everything out and start over to put it in conduit. However, if you're extending or modifying that circuit, the new part absolutely needs to be in conduit. This blend of grandfathering existing setups while demanding modern safety standards is typical in electrical codes. Let's zoom in on why an M cable that common Romex wiring isn't suitable for the switch leg unless certain conditions are met. Think of an M cable as designed for indoor, dry environments. It's not built for the harsh conditions near a pool, which can be damp and corrosive. If a fault were to occur, and the NM cable wasn't properly protected, it could energize surrounding materials, creating a shock hazard. That's why the code mandates conduit or other approved methods to shield the wiring. The 6-foot rule comes into play if you transition from conduit to NM cable. The idea is to keep the vulnerable NM cable as close as possible to the overcurrent protection, like a circuit breaker. This limits the potential for a long run of unprotected NM cable to become a hazard. Now let's contrast X10 and Jandy relays. X10 relays are like remote controls that send signals through your home's electrical wiring. They are convenient, but they can be finicky. Interference from other appliances can disrupt the signal, and they might not always be the most reliable. Jandy relays, on the other hand, are hardwired. They are directly connected to the electrical circuit, providing a more consistent and dependable connection. From a safety standpoint, both can be safe if installed correctly. The key is to ensure they are rated for the voltage and amperage of your pool lights and that they are wired according to the manufacturer's instructions. Remember, a GFCI is your safety net. It constantly monitors the current flowing through the circuit. If it detects even a tiny imbalance, indicating a potential shock hazard, it trips the circuit in milliseconds, cutting off the power before anyone gets hurt. GFCIs are mandatory for pool lighting circuits, and they are a critical part of a safe pool environment. Let's talk about grounding. Grounding is the process of providing a safe path for electricity to flow back to the source in the event of a fault. This path allows the circuit breaker to trip, cutting off the power and preventing a shock. In a pool lighting system, the conduit, the metal parts of the light fixture, and the grounding wire all work together to create the safe path. Proper grounding is essential for preventing electrical shock, especially around water. Now consider the different types of conduit. Rigid metal conduit, or RMC, is the heavyweight champion. It's made of thick steel and provides excellent protection against physical damage. It's often used for underground installations where the conduit might be exposed to rocks or other hazards. Electrical metallic tubing, or IMT, is a lighter weight option that's easier to bend and cut. It's suitable for above-ground installations where physical protection isn't as critical. PVC conduit is a plastic option that's resistant to corrosion. It's often used in areas where the conduit might be exposed to chemicals or moisture. When choosing conduit, it's important to consider the environment in which it will be installed and the level of protection that's required. Let's address some common mistakes people make when wiring pool lights. One mistake is using undersized wire. The wire must be sized appropriately for the circuit's amperage to prevent overheating and potential fire hazards. Another mistake is not properly grounding the system. Branding is essential for preventing electrical shock, and it's important to follow all applicable code requirements. A third mistake is using improper fittings and connectors. The fittings must be designed for use with a specific type of conduit, and they must be properly installed to ensure a watertight seal. Finally, remember the manufacturer's instructions. Every piece of equipment, from the lights to the relays, comes with specific instructions. Following these instructions is critical for ensuring safe and reliable operation. The NEC, or National Electrical Code, is a comprehensive set of standards for electrical installations. It's updated every 3 years to reflect the latest technologies and safety practices. Local jurisdictions often adopt the NEC as their electrical code, so it's important to be familiar with its requirements. The NEC covers everything from wiring methods to grounding to overcurrent protection. It's a valuable resource for anyone working with electrical systems. In conclusion, wiring pool lights safely requires careful planning, attention to detail, and a thorough understanding of electrical codes. It's not a job to be taken lightly, and if you're not comfortable with electrical work, it's best to leave it to a qualified electrician. By following the code, using proper wiring methods, and consulting with a professional when needed, you can ensure the safety of your pool lighting system and enjoy your pool without worry.